Welcome to the Right Science Daily Revision Boost. First thing, we need to give our congratulations to our top 3 scorers from day 3, which is Izzy, Alishba and Molly. Well done folks, let's see if you can do it again next time. The daily formula for today is that for force. So the force in newtons is the mass in kilograms times the acceleration in meters per second squared. Today's biology blast is focusing on microscopy. So the first type of microscope we can use is the light microscope. You need to be able to identify the parts of it which are in the diagram on the right there. So you look through the eyepiece lens, you can change the objective lens to different magnifications, the slide is put on the stage and you focus it with either the coarse or fine focus. Key thing to remember is you always start at the lowest position and then you move up. There are 2 calculations you could be asked to do with regards to microscopy. First one is to work out the magnification using the eyepiece lens times the objective lens. Or the second one is to work out the size of a specimen, and they will give you the picture and you've got to measure it carefully with a ruler first of all and then divide that by the magnification it tells you in the question. When we think about cells, the first thing to remember is that many of them are colourless, so we need to use stains to make them more visible. One stain might colour the whole cell, whereas another one might highlight a specific structure. 3 stains to remember: methylene blue makes the nucleus easier to see in animal cells, iodine makes the nucleus easier to see in plant cells, and crystal violet stains the bacterial cell walls. The second type of microscopy is electron microscopy. And we need to know a key definition here for resolution, which is the smallest distance between 2 points that can be seen as separate entities. Reason we use an electron microscope is because the light microscope won't let us see structures smaller than 0.2 micrometers. We've got 2 types of electron microscope: the transmission electron microscope or TEM, which produces the most magnified images, and the scanning electron microscope or SEM, which produces 3D images of the surface. You need to be able to compare the light microscope and electron microscope. So the light microscope is cheap to buy and operate, it's small, it's portable, it's got a resolution of up to 0.2 micrometers. The specimens can be either living or dead, and it's easy to prepare those samples. And we see the natural colour unless we apply a stain. If we think of the electron microscope, it's expensive to buy and operate, it's large and not portable, it does a resolution up to about 0.1 nanometers, specimens have to be dead, and it's black and white images that we produce other than if we add false colour later. Make sure you remember today's daily formula: force in newtons is the mass in kilograms times acceleration in meters per second squared. Our chemistry check today is looking at the first part of C2 and the different formulas. When we're talking about the relative atomic mass, that's the mean mass of an atom of an element compared to 1/12 the mass of an atom of carbon-12. The relative formula mass is the mean mass of a unit of a substance compared to 1/12 the mass of carbon-12. And to work out that relative formula mass, we add all the relative atomic masses from the periodic table together for the particular compound we're looking at. A few key rules when we're thinking about our chemical formulae to bear in mind. When we see a capital letter, that tells us it's a new element. The number to the bottom right of a symbol tells you how many of that element are present. A number in front of the formula tells you there are that many molecules present. And if we've got brackets and a number after it, then you multiply everything inside the brackets by that number. When we talk about the empirical formula, this is the simplest whole number ratio of the atoms of each element present in a compound. In order to work it out, we find the highest common factor, we divide the chemical formula by that highest common factor, and then we've got our empirical formula which we can write down. When we're thinking about purity, a pure substance consists of one element or compound, whereas an impure one contains more than one element or compound. If we talk about a mixture, that's more than one element or compound mixed together, but they're not chemically bonded. And an alloy is a mixture of a metal with one or more other elements. Key way to determine if a substance is pure is by its melting point. A pure substance will melt at a single temperature. An impure substance will have a lower melting point than what we would expect. It will melt over a range of temperatures, and what we find, the greater the difference in temperature from that of our expected value, the lower the purity is. Another reminder of our daily formula for today: force in newtons is the mass in kilograms times the acceleration in meters per second squared. Today's physics prep is looking at current, resistance and those characteristic graphs. When we're talking about current, we are talking about the rate of flow of charged particles or electrons. And in order to make that current flow, we need some kind of a power supply to produce a potential difference. We also must have a complete circuit. If we think about series circuits first of all, the current is the same everywhere in a series circuit, and we can measure that using an ammeter. The voltmeter can be used to measure the potential difference across a component, and we have to connect them in parallel to the component. And what we find is that the readings on all voltmeters across the components add up to the reading across the battery. If we consider parallel circuits, then the current in all of the loops will add up to the current near the battery, and the potential difference across each component is the same as the potential difference across the battery. We need to consider the practical aspects of how we can check circuits we're using for an investigation. So if it's not working, the first thing to do is connect the bulb to the battery, and if that doesn't work, try another battery. If changing the battery doesn't make a difference, change the bulb. And when we've got those lighting up, then what we need to do is replace one lead at a time, because if you replace two or more leads at once, then you have no idea which one was wrong. When we're talking about resistance, this is measured in ohms. And Ohm's law tells us that current is proportional to the potential difference if the temperature does not change. Hopefully we remember that a metal is made up of positive ions arranged in a regular pattern, and they've lost these electrons from their outer shell. So we've got delocalized electrons, and they are free to move. When those electrons collide with the metal ions, we produce resistance. For different components, we can produce what's called a characteristic graph. So on the far left, we've got a linear circuit element like a resistance wire or a fixed resistor, just a straight diagonal line there. A nonlinear circuit element is a component the resistance does change. For example, our filament lamp, which gives you that S-shaped graph. And the last three characteristic graphs we need to recognize is that for the diode on the left there. So because it only goes in one direction, the negative you can see is horizontal, it's not going anywhere, and then it increases on the positive. The thermistor, and you can spot the thermistor because the x-axis will be temperature, and you can see it decreases with increasing temperature. And the LDR, the x-axis is light level. So do look at the axis labels for these. Our final reminder of our daily formula for today: the force in newtons is the mass in kilograms times acceleration in meters per second squared. Now we've had a quick recap, then head on over to socrative.com and test your knowledge on the topics from today. The room name you need to enter is Right 2662. Good luck! If you're unsure of any of the topics we've gone through quickly today in our daily booster, then for biology it's B1's playlist, which has microscopes. It's the C2 playlist for chemistry, and it's P3 playlist for our physics on circuits.